AGI Beyond LLMs, how to reach human-like AI. So before I start, let me give some context. Um, I believe that LLMs are extremely powerful and they're here to stay. But evidence seems to suggest that we will not get to AGI using just LLM technology. Now, another default assumption here is that getting to AGI as soon as possible is actually a good thing. And furthermore, I believe that cognitive AI approach is the one that's needed to get us there. So let me start by giving you a little bit of context, bit of background of my journey, how I got to giving this talk, basically. So I started also as an electronics engineer. That actually gave me some good insights into sort of cybernetics, analog feedback systems, and things like that. But my electronics company very quickly turned into a software company because I fell in love with software. And we ended up producing a very comprehensive accounting system that was very successful. Company grew from the garage to 400 people. We did an IPO. So that was awesome. Love to do that again. And that got me to a point where I had enough time on my hands to think about how can we make software intelligent? How can we get software that can think, learn, and reason the way humans do? So I took 5 years to study all different aspects of intelligence. How do children learn? How does our intelligence differ from animal intelligence? What do IQ tests measure? And so on and so on. In fact, I looked at even the most fundamental things in epistemology, theory of knowledge. How do we know anything? How can we be certain? What is reality? And, also I studied, of course, what had already been done in the field of AI over the years. So that brought me to a point where I realized that the field of AI had really lost its way a long time ago. The original dream of AI, when the term was coined some 50, 60 years ago, was to build thinking machines that can think, learn, and reason the way humans do. Now, originally they thought they could crack this, in a few months or a few years, but of course it turned out to be much, much harder than that. So what happened is that AI, the dream of thinking machines, really turned into narrow AI, to take a particular single problem and to figure out, with using really human intelligence, how to build computer software to solve that particular problem. A perfect example of that, of course, is IBM's Deep Blue, chess champion. But the same thing applies to container optimization and medical diagnosis and things of that nature. So around 2000, I got together with some other people who felt that the time was ripe to go back to the original dream of AI, to build thinking machines, that hardware and software technology had progressed sufficiently to go back to try and tackle that difficult problem. And we actually decided to write a book, and three of us came up with the term artificial general intelligence, or AGI. That was around 2002, maybe 2001. And that is really now the dream of going back to the original AI. Now, there are a number of ways of carving out what AI is and the different types of AI and what will get us to AGI. One fairly useful way of looking at this is what DARPA calls the 3 waves of AI. And the roughly carved out is the first wave is what is now also called good old-fashioned AI. That's mainly logic type approaches to AI. Expert systems, again, Deep Blue would be a good example of that. And then the second wave, of course, hit us like a tsunami about just over 10 years ago. And that's all about big data statistical systems. And in fact, it's a way of getting neural networks to do something really, really useful. And it's been a revolution, of course, and we are still in the middle of this second wave. The third wave, however, really addresses the cognitive requirements of what is human-like intelligence, not just being able to solve specific things at a human level. I mean, we did that. We've been doing that already for 30 or 40 years, like world chess champion. But to be able to think and reason and conceptualize the way humans do, which gives us ultimately the power to discover new things, and that's the real power of human intelligence. So it's not so much saying of what is intelligence and trying to go crazy on trying to find a definition, but what kind of intelligence do we need, and that ties into what we expect from AGI. Now, what the conclusion I came to in studying intelligence, including psychometric testing and so on, is that to learn conceptually in real time as you interact with the environment, with other people, or read things, or watch videos, or whatever, that interactive real-time learning and adjusting your knowledge is really, really important for discovering and for solving problems. So one can contrast that as well, of pretty much all the AI that is being done now, where the problem is really being solved externally from the AI, by the data scientist, by the programmer who comes up with the algorithms or the particular configurations, the parameters, the data sets that need to be provided and prepared in a certain way, and how to tweak and tune the system to ultimately solve a particular problem or particular set of problems. There's another big misconception about intelligence, and that intelligence is about having knowledge. And often people are deemed to be intelligent if they're very knowledgeable, but that's actually wrong. It's somebody with very little knowledge. You could take somebody out of a village in Africa who has very little knowledge about things in the world, but is highly intelligent. So it's the ability to acquire new knowledge and to be able to reason about it, and to build on knowledge, to have transfer learning, basically things you learn in one context you can use in another context, and being able to do that largely autonomously. So most of the AI we see, almost all of the AI we see, it's really about having a lot of knowledge, not how it's acquired. And that it's, the knowledge is also fixed, and it's really externally generated by the programmer or the data scientist. So what we're looking for is really to have systems that are more autonomous and more adaptive, meaning that they can adjust in real time to new information and integrate that and draw conclusions from that. Now, let me talk about why I think AGI is so important, so wonderful. So imagine being able to train up one AI to be a PhD level cancer researcher, that the system can hit the books, can learn, can study and basically learn similar to the way a human would, to learn all of this, the knowledge and skills you need to be an effective cancer researcher. Now imagine making 1 million copies of that AI. You now have 1 million PhD level cancer researchers chipping away at this problem. Of course, we will make much, much more rapid progress. And now imagine this in every other field, whether it's nanotechnology, whether it's, other diseases, whether it's aging, whether it's energy, pollution, or governance, just being able to have a lot of smart AIs being able to pursue whatever problem area we want to. And furthermore, it'll be with all the benefits that computers have over humans, that they inherently have over humans. So, for one, they can be significantly less expensive than humans. So you can afford to have many more of them, chip away at the problem. They'll communicate much more effectively. They can transfer knowledge at much faster data rates than than people can. Also, they don't have their egos getting in the way to prevent, sharing of information. So sharing of information will be much more effective. They can learn much quicker. You can speed up things, and they can learn 24/7 or operate 24/7. So just the speed up, the efficiency is much greater than for humans. They also don't have certain, call them distractions, that humans tend to have. And of course, they have perfect memory, potentially. They have access to all of the information in the world at their fingertips, basically by thinking about it, much more integrated than humans have. And they are much, much better at logical thinking than we are. After all, rationality is an evolutionary afterthought for humans, whereas in computers, it can be, computers inherently designed to be able to think very logically. So there are many, many benefits of having AIs doing research. Now, the second bucket, I mean, having AI researchers like that is tremendously useful for humanity. The second thing is just being able to automate a lot more tasks, and just leading to a massive cost reduction in goods and services across the board, the kind of extra wealth that will create across the world. Now, there's a third bucket that I like to sort of identify that I think is really important, and why I think AGI is so desirable. And that is as what we call a personal assistant, or really a personal assistant. Three different meanings of the word personal come into play here. The one is it's yours. You own it. It serves your agenda, not some mega corporation's agenda. The second personal is it's hyper personalized to you. So it learns your history, your goals, your wishes, your priorities, and so on. You're not just a number or a statistic or a demographic. And the third personal is that of privacy, that you decide what it shares with whom. Some of the things that you share with your spouse, other things you share with co-workers, and some things you share with Amazon. So I think in these three sort of major buckets of benefits, I think we could see the tremendous promise of how AGI can improve human flourishing. And I think through this explanation here of how I see AGI benefiting us, one also gets a good idea of what AGIs need to be capable of. They need to be able to autonomously learn new things, to discover new things, to do things without constantly having a human in the loop to verify what they're doing, or to continue prompting them and trying different prompts. So we are at a unique moment in history, because a year ago ChatGPT became available, and it really bowled us over. I mean, it's amazing technology. What it could do, I think probably just about nobody could predict that it could do what it can do. That it can create such coherent natural language, conversation output, and so on. It's really quite phenomenal. So I think it's sort of given us a taste of what AGI can bring. It's demonstrated the potential of where AI can go much more strongly than other AI developments had in the past. So I think there's already that taste in the air of what AGI can bring. And of course, it's generally acknowledged what the power and value of AGI is, even though people tend to be quite confused generally in terms of how to specify it or what exactly it means. But I think it's definitely true that this will be extremely transformative, much more than electricity or internet. And I think there's consensus around that. And it's, people are putting their money where their mouth is, the amounts of money being raised for seed rounds. I mean, 1.5 billion seed round essentially for a company that has, no revenue and no product is phenomenal. It really shows that people believe there is something there. We are getting close to AGI, or to really powerful AI. Now, the problem is that there's also a recognition, and increasingly so, that the big data GPT approaches are not the path to human level AI. And it's kind of an unspoken secret, among researchers in a way, because there's a tension between talking about, getting investments and being able to say, our technology, we can develop this to AGI, whatever that means. But yet researchers also know, paper after paper, and privately and to a large extent publicly even, people acknowledge that this is not going to get us to AGI. And nobody less than Sam Altman said that we will require new ideas. Okay, there was an April. Maybe by now he's got a different tune, but generally there's still the consensus that large language models by themselves are not going to do it. Demis Hassabis, not solve AI, not by a long shot. And some more quotes. I mean, you can see lots of them. So what are those limitations, and are they fixable? So hallucinations. They are really an inherent part of large language model architecture, of the approach. You basically have a system that was trained on trillions bits of information, good, bad, and ugly. And it tries to, whenever you give it a prompt, you ask it something, it tries to come up with some kind of coherent response based on this mass amount of information that is there. But as I say, it's good, bad, or ugly. And this is really why it, what's called hallucinates, why it makes mistakes, makes up stuff completely. So it's unpredictable. It may hallucinate, it may give you something very useful, but you really need a human in the loop to make sure. Secondly, the inability to learn in real time. That's really, really important. And that's an inherent part, again, of the architecture. Imagine hiring a human assistant that comes to you and they can do, Excel and Word and a whole bunch of other things they know how to do. And you tell them now, well, we introduced some new products, we closed down one of our branches, we have a new relationship with this business relationship with this person. And the next day, your assistant comes in, they've forgotten all of that information. That's not really going to be very useful. And furthermore, as you tell somebody, this new information, they need to really update their model, because it may affect other things, and that they know about. That we discontinued this product. Okay, it means you can no longer sell it, or are you going to have a replacement product? What are the consequences of that? And to try and fix this limitation in large language models through fine-tuning and additional training, they hit up against catastrophic forgetting. Then basically, if you try to add new information to a large language model, it can catastrophically forget stuff that it used to know before, and you never know what it's going to forget. So that's a severe limitation. It's a black box. It's not auditable. It's not safe. So there's really nothing you can do about that. And in fact, there are laws coming out saying that you have to have explainable AI. Now, I don't know how much they're going to be enforced, but in Europe, for certain applications, you cannot use a black box AI. So it clearly is a severe limitation, that if you can't trace how a system came up with their answer. And lastly, it has very limited understanding, because it's really not grounded in the real world. So there's only what it can infer through all the massive amounts of language data that was trained on. And there's also no metacognition, that is very, very important in human intelligence, that we can think about our thinking, that we become aware of how certain we are, or whether we thought enough about it or whether we need to think more about something. So that metacognitive component is extremely important, and it's hard to see how that can just be glued on top of it. Actually, there is one more point, and that, of course, it is extremely expensive, which is a real practical limitation. When building a model costs more than $100 million, then every time you want to experiment, you want to give it new information, you're looking at massive outlay, and only a few companies can afford that. And similarly, it's basically getting data is becoming harder and harder and more expensive, because you're running out of all of the free cheap data, and in fact you're running out of data altogether. So by and large, these inherent limitations are not fixable. And in fact, the word GPT already gives you a very good clue to these same things. G, it's generative. It makes up stuff basically based on what it was trained on. P means it's pre-trained. It's trained at the factory, with $100 million expense or whatever. And it cannot really learn in real time. It cannot update its model in real time. It's pre-trained. And the third one is using transformer technology, and that's inherently using backpropagation, which means it needs massive amounts of data and massive amounts of training time or training compute. So that it's very inherent in the technology. So what is the solution? We believe that a cognitive AI approach is the way to go. Now, my company and I have been working on this for the last 20 years, and we have built initially various prototypes, and we built commercial versions of it. We've expanded the technology and also commercialized the sort of second generation of it. So we have quite a bit of practical experience with that, where we can actually demonstrate that it can learn incrementally in real time with one-shot learning, few-shot learning, that the knowledge can actually be grounded in experience, that it can have logical reasoning, it can have metacognition, and ultimately it can, have scrutable imagination and creativity. So we've already demonstrated that a cognitive AI approach can in fact solve these problems. Now, if I, for example, compare Inflection's Pi personal assistant, here's a comparison. It has all of the limitations of large language models. Now, of course, it does have this huge knowledge base that large language models have, that are trained with, billions, trillions of pieces of data, which you don't have that massive amount of information. That's exactly the trade-off, that you can train a very useful, scrutable system with very limited data. So it's the quality of the data that is important, not the quantity of data. So we see it playing out in this way, that, as we kind of, in DARPA's way of looking at things, that you had the first wave of, call them rule-based, logic-based systems. We then moved into the second wave, which has given us so much more new technology. I mean, autonomous driving wouldn't be possible without the breakthroughs in deep learning, machine learning. We have language translation, speech recognition, lots of breakthroughs, AlphaFold, very powerful technology that we've got through essentially deep learning large language models. But we don't believe, the evidence really indicates that it's not going to get us to AGI. So we believe it's cognitive AI that is needed to achieve that. So what I've shown and what I've spoken about, how is that possible? How can cognitive AI overcome these problems and actually get us to AGI? Now, the approach that we have and that we have, practical experience with, um, is it's a special cognitive architecture. So that really starts with the question of, what does intelligence require? What are the cognitive elements that are really important in the kind of intelligence that we want? And as I've mentioned, of course, that is real-time learning, but it's a special kind of learning. It's conceptual learning. It's to be able to generalize, to conceptualize in a contextual way. So it's having the right kind of cognitive architecture and having learning algorithms that can actually learn in real time with very limited data. So that means there's no back propagation, or at least that does not form any crucial part of the approach. It's a knowledge graph, so it's inherently scrutable. You can basically track down the knowledge graph and see how the system came to certain conclusions. It's actually a vector graph database or knowledge graph, a very special kind of combination that we have. So in principle, you can follow through how it comes to a certain conclusion, how it learns, what it learns, and so on. I say in principle because obviously some things are inherently extremely complex, and it might require very sophisticated tools and quite a bit of effort to track down the whole history of, all the different inputs that come to a certain conclusion, that lead to a certain conclusion. We also have, as part of this, explicit ontologies, so things that are facts that can just be learned. Obviously, a lot of what's in Wikipedia are facts, or at least opinions, but you can say whose opinion it is. And the other important approach to make this more tractable is that what you're really building is, you don't have to build something that competes with ChatGPT as far as the amount of knowledge is concerned. What you really want is, you want to build something like, I don't know, say a 12-year-old, a smart 12-year-old that is at a point where he can hit the books and learn largely by himself. So that's the idea of seed AI or seed AGI, where you have a system that really doesn't have a lot of knowledge, but it has the crucial knowledge of how to learn. It has the skills, the learning skills, the reasoning skills, and uses that to bootstrap all of the life skills and life knowledge that it needs. Of course, it'll also be an extremely strong tool user, which is, again, something that makes humans so powerful relative to animals. So it will be able to use all sorts of programs. It'll be able to use ChatGPT and other large language models. It'll be able to use Wikipedia and so on, which is actually much more powerful than having static information, because it can use new tools as and when they become available. Here's a bit more about the architecture that we have. So it's a super high performance vector graph that encodes all of the knowledge and skills. And at super high performance, we actually benchmarked it. It is literally 1,000 times faster, 1,000 times faster than any commercially available graph database. And I have actually two white papers that might be of interest. The one is, why don't we have AGI yet? And the second one is a more direct path to AGI. And we actually show the benchmarks that we did there, knowledge graphs. We also, in that white paper, we also have a benchmark about learning new facts in real time that we benchmarked against ChatGPT 4. And it did extremely poorly on that. We benchmarked it against Claude 2. And even there, it only got, I think, 37% accuracy versus our approach, which has essentially 100% accuracy on that. So super high performance vector graph database, and a highly integrated core of all of the key cognitive features that you need, or cognitive algorithms that you need, that they talk to each other, they talk to the knowledge graph in a very, very efficient manner. So for example, when you are trying to make sense of a sentence or a paragraph, it uses current short-term memory and as well as long-term memory, and also uses a reasoning ability to actually figure out what each sentence means. So it's not a pipeline that it goes through, but it's an integrated whole that basically can be much more efficient at extracting the right kind of meaning and therefore giving the right response. So really where we are right now is, I think, with the excitement of large language models and the whole idea of getting to human level AI, I think it's really perfect timing to push for human level and human-like AI, basically AGI. One of the benefits we do have now that we didn't have, 2 years ago, was that it's actually quite feasible now to use large language models to help train a system, but not with all of the data, but curated data, basically, that can be cross-checked and validated rationally. And I think that really promises to get from that seed AI stage to full level, human level AGI, and to get us to AGI level researchers and personal assistants largely by itself, by the system learning by itself with some human help. So it's a very exciting time to be in this field. And I believe that we actually have a very good opportunity, a company, IGO AI, to be able to make progress to achieve AGI, because we have a lot of experience with cognitive AI, both on the development side, on the theoretical side, as well as on the practical side, and being able to commercialize it. So I think that's really all I have for now. Thank you. Now, I have had a few questions come through that I'd like to respond to. So first question is, how do you prevent your AGI learning incorrect information? So first of all, it's not infallible. I think anybody who believes that AGI will be omniscient, will be godlike, is sadly mistaken. There is no such thing as infallibility in knowledge. So the system will make mistakes, but it will make fewer mistakes than a smart human, because it is inherently more rational. It'll be able to draw on different data sources more easily than we as humans can. It won't have sort of the ego getting in the way. So it'll avoid many of the biases that humans have in reasoning and decision making. It will also know when it doesn't know something. So it will have a level of a sense of certainty, and more than a sense, it'll have the evidence of how certain it can be. So I think there are many ways in which inherently it will be much more capable than humans, but it will not be infallible. And again, this is where a community of AIs can help, because like humans, we can cross-check each other, where different AIs will have gone through, will have studied different things or worked with different things, or might have a different perspective, and they can cross-check each other. Next question is, why will AGI do the right or the right moral thing? So I guess a tricky question here is what one exactly means by morality and what is right or wrong. But if the standard here is human flourishing, which I think it should be, that's what we want. We want humans to have a better life, to be healthier, wealthier, healthier both body-wise and mental health, and wealthier in all respects. AGIs will help us tremendously with that, and that'll be a positive moral influence. But I actually go further than that. I believe there is such a thing as a rational approach to morality, to basically say, what are the kinds of attributes, what are the kinds of virtues, I guess we could call them, that encourage human flourishing. And this is where this personal assistant that we have, if we each have one, it can help us make better decisions. So it'll be a bit like having a little angel on your shoulder that can actually help you make the right decisions that'll encourage flourishing of you and the community. So I think it'll be a tremendous help in actually fostering morality and doing right things more often than not. How do we know that self-directed learning is impossible for LLMs? Well, we don't know that for sure, but I don't see any proposals that anybody has, and there are lots of papers that are published, and a breakthrough like it would probably become quite visible quite quickly. And typically, the approaches at LLMs of being able to learn have taken two paths. The one is basically to increase the input buffer size, and that is why Claude 2 did much better than ChatGPT in this particular benchmark that we ran. So if you can have more in memory, then obviously it kind of somehow learns things, at least temporarily. The problem is it's also been demonstrated that increasing the size of the input buffer of the context window has severe limitations, that it tends to scramble up information that's in there, tends to focus more on things that are either at the beginning or at the end, and that may change depending on the particular architecture. But the problem is what is in the buffer is not integrated, does not update the model itself. So the other approach of trying to have systems learn in real time is to have an external database, to have an external vector database that basically you can push facts into that database and then extract facts back out of that. But again, it has the same limitations, that it's not integrated into the main knowledge graph, into the main model of the large language model. And it has to know basically reliably when to call up something. But further, much more importantly, information in that database doesn't affect directly the information that it has in the model. So it's not really a solution. I already mentioned fine tuning, where you have catastrophic forgetting. So I don't see anything on the horizon. It seems to be inherent. Again, as I mentioned, GPT, the P is pre-trained. Transformers really force you into pre-training with the backpropagation approach. How can your graph database be 1,000 times faster? Well, let me say it's part of the secret sauce. I'm quite happy to talk about it privately to people interested in it. But I can say that the reason we have such a incredibly good performance is that we designed our graph database specifically for this purpose. And it's optimized for this purpose and fully integrated with all the cognitive algorithms required. So last question here. If your cognitive AI is the right path to AGI, why is all the money going into generative AI? Yeah, good question. I think it's an accident of history in a lot of ways. It's because large language models, or deep learning, I should say, has been so incredibly successful in the last 10 years. It's become self-reinforcing, that basically it's the only game in town. In fact, people who entered the field of computer science or AI in the last 10 years don't actually know of any other approaches, techniques. Their reward is to publish papers on deep learning and large language models. So it's kind of reinforcing the success has reinforced the the monoculture, I think one should call it, of big data, machine learning approaches. So that's one thing, that you basically, all of the experts, that's really the only thing they know. So they're not looking anywhere else, and they are not rewarded for looking anywhere else. They can't get papers published if they on some other thing. They can't get a PhD. They can't earn the big bucks. They can't get their company funded. So it's basically a self-reinforcing monoculture. Then also from an investment point of view, I think primarily or specifically from the dot-com era, investors have become very much momentum investors. There is really very little value investment now. It's all momentum. Basically, what's going up, that's where I need to put my money. Where's everybody else putting money? Because that's what's going up. So it's very much momentum investing. So it's people jumping on the bandwagon that has momentum. And clearly, large language models have momentum, no doubt about it. So I think there's that self-reinforcing thing on the financial side as well. But there's a third item I'd like to highlight here, and is rather disappointingly, the term AGI was coined more than 20 years ago. And a lot of people have been talking about AGI. It's become very common. And yet, very, very few people in the world are actually working directly towards AGI. And that is true even for companies that are supposedly dedicated, like DeepMind. DeepMind has had virtually unlimited resources for 10 years. And yet what they're working on is not trying to understand intelligence, but rather doing what they can do. Hey, we've got a lot of data. We've got a lot of compute power. We've got fancy reinforcement algorithms. We can train games for themselves, or we can make some progress in protein folding. Fantastic. It's great that we have that, but it's not AGI. AGI is general intelligence. It's not the ingenuity. Again, it's not the ingenuity of your data scientists and your engineers who can figure out how they can use these big data approaches and big computer approaches to help with protein folding. I say it's terrific that they're doing it, but it's not AGI. So there are very, very few people in the world even trying to solve that problem. And my one white paper is specifically about that. Why don't we have AGI yet? Now, something related to that is what I call the narrow AI trap, that those few teams, or those teams who have at times tried to work on AGI to try and figure out how we can have this general real-time learning, conceptual learning, contextual learning system, tend to have pressure, either internal pressure for themselves to show quick results, to show impressive results, or from their shareholders, or if it's an academia. And then basically what happens is, to show impressive results or to beat existing benchmarks, you end up hard coding things, you end up building narrow AI solutions that give you impressive performance, but it's going away from solving the problem of AGI. So you really need to focus steadfastly on what does intelligence require, and to build on that, and ignore benchmarks that are irrelevant, and to ignore being able to publish papers that may be interesting or compelling. And you need to obviously have an investment horizon that doesn't expect to have results that will blow away the competition. That's one of the problems you have between OpenAI and Google and Amazon. The teams are always trying to, and Facebook, the teams are always trying to come up with better benchmarks, or something that'll clearly be superior to clearly be superior according to the sort of current benchmarks and goals. And early AGI won't be that impressive unless you assess it from the perspective of what does AGI require, and is it impressive in that regard. So I think it's unfortunate that we have this dynamic. We are benefiting certainly from all the money going into generative AI and statistical AI, but it has sucked the oxygen out of the air for any other approaches, and specifically for the approach needed to actually get to AGI. Thank you.